Hi, welcome to Lesson 12E, Operations with Plane Vectors. The goal of today's lesson is to understand and effectively demonstrate mastery of vector arithmetic. So we've been looking at vectors over the past couple of days, and so what I'd like to do now is take a look at this vector. We saw that a position vector, and in this case position vector 4, 3, is basically a vector that's pointing to a point, and this point is P, 4, 3. Notice, of course, the difference in vector notation and point notation. And so this position vector begins at the origin and points to the point and is represented by 4 unit vectors in the x direction, followed by 3 unit vectors in the y direction. So that can be given as OP43 as stated here, that translation vector, or it can also be written as 43 equals 4 unit vector I plus 3 unit vector j. And of course it can also be 4, 1, 0 plus 3, 0, 1. Okay, so those are the different ways of showing this. So now, what if I wanted to then go from point P up to this other point Q, and this point Q has coordinates 6, 10. So if I go from point P up to point Q, I'm going to draw this vector like this, and this point 6, 10 would have position vector. Well, if I go from the origin all the way up to that point, well, that position vector would be 1, 2, 3, 4, 5, 6 unit vectors in the x direction, followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 unit vectors in the y direction. And that gives us to 6, 10. But what about this vector here that goes from 4, 3 to 6, 10? Well, if the x coordinate of this point is 4 and the x coordinate of point Q is 6, it would stand to reason that we have gone 2 unit vectors in the x direction from point P, followed by 7 unit vectors in the y direction from point P, or from that y value of 3, up to reach this final point Q, 6, 10. So in the x direction from the origin we've gone 1, 2, 3, 4, followed by 1, 2, and that gives us that 6 for the x direction. And then we've gone 3 units in the y direction, followed by 7 units in the y direction to give us that 10. So it would stand to reason that if we have some general vector A, which can be written as A sub x, A sub y, and then we have this other general vector B, B sub x, B sub y, then if we're to add these two vectors together, we could write it as A sub x, A sub y plus B sub x, B sub y, and then that gives us A sub x plus B sub x, A sub y plus B sub y. So effectively speaking, we are adding the x components of the two vectors together, and we're adding the y components of the two vectors together. And that will give us the final resultant vector of vector A plus vector B. If we want to do any subtraction, we could do exactly the same thing. Suppose we have, I don't know, let's use values for a second. We've got vector 4, 7, and we're subtracting vector 5, 3. That's going to be the same as 4, 7 plus negative 5, negative 3. because this negative, well actually I guess an intermediate step would have been 4, 7 plus negative 1 multiplied by 5, 3. So here's some scalar multiplication. Scalar of negative 1 multiplying by the vector to give us this. And then if we were just to put those together, we end up saying 4 minus 5, 7 minus 3, to give us the final vector of negative 1, 4. Okay, so that's basically how vector addition works. Group the x's together, group the y's together, and Bob's your uncle. Scalar multiplication, just like integer multiplication, is like skip counting. So if we're going to see how many groups of, say, 9 we can that are needed to form 36, we have 9 plus 9 plus 9 plus 9, or 4 times 9, and that gives us 36. Same sort of idea with vectors. If I said 4 vector r, well, we can see that was not equal, but we can illustrate this as 1 vector r followed by another vector r followed by, of course, another vector r followed by one more vector r. Okay, and that's the same as for vector r. So it's just vector multiplication, sorry, scalar multiplication, is we would just take a scalar and multiply by the vector to give us the new vector. So there can be combinations of scalar multiplication with vectors. Vectors that get turned around by multiplying by a negative, and addition of vectors. So all that is wrapped up into one fun little package here in section 12e. And so what I'd like you to do is take a look at any examples in the textbook in section 12e. We're going to be taking a look at some examples in class tomorrow. And then in the meantime, I'd like you to take a look at these practice questions briefly, just to see what's going to be entailed for you tomorrow. And that pretty much wraps it up. So thanks for watching, and we'll see you in class.